Hello, welcome to another video. After the after understanding what is spanning tree and minimum spanning tree, we are going to understand what are the algorithms used for finding the minimum spanning tree of a given graph. Now you can see that there is a graph given here, and there are two most famous algorithms which are going to tell us how you can find out the minimum spanning tree of this particular graph. If you look at the names are a bit difficult to pronounce. That's a different thing. This is called Kruskal's algorithm and another Prim's algorithm. Among these, Kruskal's is the most easiest one, and the Prim's is also easier. But among these two, Kruskal's is the most easiest one, and that's why I am going to cover Kruskal's algorithm first, and later we will try to understand the Prim's algorithm. Now, if you look at this particular graph, I have taken it here, but there is bit difference between the vertices. Don't worry about that. Now, see, there will always be two steps when you are finding minimum spanning tree of a given graph. In this particular case, step one is you'll arrange the edges in non-decreasing order. Non-decreasing order. There is a slight difference between increasing order and non-decreasing order. Okay, here you are going to arrange it in non-decreasing order, and then step 2, you are going to choose edges one by one, making sure that chosen edge does not form a cycle. That's all. So what I am going to do now here, now let me make some space for me, because I'll require it nearby only. Let me take it this side, and let me have a line here. Okay. Now if you take the first edge, which is G comma F, what is weight 1? This is done. Now choose this one BE. I'm going to arrange them in non-decreasing order. Means they're not increasing order. I'll tell you why it is not increasing order. Now if you take BE, it's going to be 2, and then next. This is done. And then we have got 3 edges with weight 3 are 2. So A comma C, this is 3. This is done. And E comma F, this is 3. Now if you say that increasing order, we cannot write 3 and 3 here. But if I say non-decreasing order, it will just make sure that the next number that I am writing is not less than the number that I have written previously. That's all. So we are using non-decreasing order. Now coming to the next edge, that is weight 4 BC, weight 4, then any other force. Okay, no. Now consider the next one 5, A comma B is 5, and then E comma G is again 5. This is done. This is done. And then I have got C comma D, again 5. This is done. And if you see this B comma D is 6. And then next E comma D is also 6. Okay. And then D comma F is also 6. And C comma F is also 6. Okay, this is going to be 6, and this is 6. Now, if you count the number of edges 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 edges. Just verify once whether you have written all of them or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have covered all the edges. Now what we are going to do is we are going for the step 2. Now whatever I have done is step 1. I have simply written all the edges in non decreasing order. Okay. Now what I am going to do is I am going to write stepwise. I am going to choose edge one by one. The first edge that I am going to choose is the minimum edge. Okay. For that, what I am going to do, there is a special format. We can follow that one. You can write it in a tabular column. Let me write a step here, and then edge connected, edge, and then connected components, and then the graph. Okay, this is going to be the table which I'm going to write. This is the initial step. Let me take a different pen. It is the initial step. In initial step, we have not chosen any edges. We have not connected it to the main component. And in this particular case, you can observe that initially we will have a graph which is not connected at all. 1, 2, 3, 4, 5. Now you see, if I write 1 and 2, you will find that 1 and 2 are connected this way. If I write 1, 2, 3 in this place, in this, then I can say that some way 3 is connected to this. That's all. Just this is a way of representation. Yeah, most important thing is that you understand how you can solve any given question. Now in step 1, we are going to choose the first edge, that is GF, because the weight is 1. See, we are going to start from the first edge always. So I am going to choose a edge GF. Okay, a edge GF. And when I connect GF, my graph is going to be something like this. F and G. Right. F and G, and this is going to be 1. And if you see the connected components, okay, there is a mistake here. We cannot write the connected components this one. This is actually from a book. You'll write all the vertices A, B, C, D. See, when you are not connected any of them, they will be separate. So you need to write them separately. E, F, and G. If you see, there are 7 vertices, and therefore I got 7 here. Now when I added this edge, I got one of them connected. GF. Okay. GF got connected, and write with a comma, and then still A, B, C, D, and E are separate. Means they are not added here. Just this way. This is just a way of representing. Don't worry much about this. Now coming to step 2. See, whenever you are considering, in every step you will be considering a edge. Okay. Now you can take this particular part. BE. BE is 2. This one BE is 2. This particular thing. So I'll be taking BE. When I take BE, I find that I got F, G from the previous step, and then from here I got B, E. Now our graph is going to become this much. Let me put a line here. You know why line came here. Okay. And this BE is going to be 2. And if you see the connected components now, it is GF is connected, and then see BE is not connected to this one, so you can write it separately BE, and then the remaining part is A, C, and D. Okay. Now coming to the next step. This is step 3. In step 3, we are going to consider the third edge, that is AC. You observe where is AC. AC is here, and so I am going to consider AC. If I consider AC, we'll try to draw the graph. Here we have got 2, here I have got 3, okay, and here I have got AC, okay. Now this is going to be how much? I think the value AC is 3. Write 3. Now you write which are the components connected. A comma C I can write, and then I can write B comma E, then I can write G comma F, and then still there is someone remaining, and that is D. Okay. Now we'll go to the next step. In the next step, that is step 4, what we can do, take the fourth edge, that is EF, EF. Okay. When you take EF, you should make sure that it will not form any cycle. If I try to add this EF, it is going to come here. So you can see that it is not forming any cycle. So what I can do, see, if I add EF here, it will not form any cycle. So I can consider EF. Let me draw B to E, A to C. This is 3. This is 2. This is okay. This is going to be 1 actually. There is a mistake. This is 1. This is 1 again, and this is EF. What is the value of EF? It is 3 again. So it is 3. Now if you go to the next step, we'll go on adding the edges till we have got edges is equal to number of vertices minus 1. If you see the number of vertices in this case, 1, 2, 3, 4, 5, 6, 7. So 7 minus 1, we need to get 6 edges. Okay, till then we should go on adding. Now you can see here I got 1, 2, 3, 4, only 4 edges. Now still how many edges I require? I got 1, 2, 3 and 4 edges. Still I need 2 edges. Okay. So for that I'll go to next step, step 5. In step 5, consider the next one, that is BC. See, when you consider BC, just try to add it here BC. So this is also not going to form any cycle, and that's why I can add it without any problem. BC, and here you can see I have got AC. I forgot to write here. Now I am writing AC, and here I have got B, comma E, comma F, comma G. This is G, and then I have got D separate. Still I have not added it. Now if you take BC, if I try to add BC in this case, I am going to have A, C, B, E, F. All these things are from the previous step. This is 1, this is 3, this is 2, and this is 3. I am going to add BC. What is the weight of BC? You can see it is 4. Okay. It is 4. Now if you try to write these components, just write which all are connected. A, comma C, comma B, comma E, comma F, comma G. And still one need to be added, that is D. Just keep it aside. Now in the next step, now you can observe the number of edges that I have got here. 1, 2, 3, 4, 5. How many edges we need to have? We need to have total 6 edges. I have got 5 now. I'll go for the next one. The next one is A and B. AB, this particular edge, right? I will go and check whether it is forming a cycle or what. AB. If I add AB, it will form a cycle. So just mention it here in step 5, in step 6, AB, and write this as it is, whatever is written here, A, C, B, E, F, G, because I are not going to add it, rejected, or you can write it here only, no problem. Instead of writing the components, you can write rejected because forming cycle. You can write it here. Again, we'll go to the next one. In the step 7, we'll take the next edge, and the next edge is EG. You come back, check EG, E and G. If you add it here, again it is forming a cycle. So we are going to avoid this also. So I am going to write it here. EG considered but rejected because forming a cycle. Okay. Now so we'll go to the next step again. Step 8. The next step we are going to consider CD. See, we wanted total 6 edges and now we have got 5. Now if I add this edge, I can stop it here because I'll be adding the last edge that is possible. I'm going to add which edge? CD. So right here CD. Now if I try to add CD here, how is it going to look like? D is going to be here, so CD. You can observe here it is not going to form any cycle, so I can add it. A, 3, C, B, E, F, G. It is 3, it is 1, this is 3, this is 2, this is 4, and I have got D here, and this is going to be how much? Yes, it is 5. So it is 5. Now if you look at our connected components, I can see clearly A and have C, B, D, E, F, G. All are connected. Initially I had all separate components. You can see here all these were separate. Okay, let me draw a line here. All these were separate, A, B, C, D, E, F, G in the initial stage. But in the last step, I have got all of them connected, and if I count the number of edges 1, 2, 3, 4, 5, 6, and you can actually count the cost of the obtained graph, cost of the minimum spanning tree obtained is equal to 3 plus 4 plus 5 plus 2 plus 3 plus 1. So this is going to be 9, 10, 13, 16, 17, 18. So this can be your solution. In the next video, we'll be solving the same question using Prim's algorithm. Thank you.